Hello, everybody. Kristin and we want to present the RDP performance in GPU accelerated WVD sessions. Hey, Chris, you want to introduce yourself?
Hi, I'm Kristin Griffin. I work with Benny at Rex Analytics. I also work at RDS Gurus.
Yeah, that's us. And let's get started really quickly so that we can share all the great demos that we have or the recordings that we have. Because what we want to do is we want to show you how we built the Azure WVD reference environment, basically the lab, and then how we measure the remote end user experience in the lab. And we want to answer the following questions. What is the difference between a physical GPU and a soft GPU? Soft GPU is basically the term that Microsoft uses when the CPU, excuse me, the CPU emulates the GPU. And this is when no GPU is present, but many of the applications expect a GPU to be present, so the CPU, it just emulates the GPU. And then we want to find out what the impact is of noisy neighbors that we add to a multi-user environment. There are a couple of things that we have to keep in mind when doing WVD. Number one, there's a new RDP site-by-site stack, which means when you are using the WVD client, it does not connect through the traditional RDP protocol stack. It uses a different stack, and as the name indicates, it runs site-by-site. So you can still connect internally on the Azure VNet through the MSTSC client, but if you connect through the WVD client, then it is a different protocol stack. So this is something that we learned, and we pretty much will learn more about that when Dennis Gundarev does his session later today. And another thing that we always have to do, we have to configure the GPUs in WVD VMs, and so download and install the GPU drivers, and then probably do a driver cleanup procedure. And after we have done that, then we need to activate the GPU and H264 in the group policy. This is what we had seen before in other sessions as well. The thing is that if we forget to do that and we run a test, it's not valid. And we have done that several times, and so we burned hours, and then suddenly we found out, we have not activated it. So this is something that happens every once in a while. Okay, but the biggest problem was there is no performance counter for remote end user experience. So we have to find a way to measure the remote end user experience. And if you have seen my first session, I referred to an environment where the user connects to the primary user from his endpoint device to the EUC environment. And in our case, the EUC environment is GPU accelerated. In the EUC environment, we install our workloads, our personas, and a couple of tools because we want to collect telemetry data, and this is why we need our own tools. The workloads are is work that an individual user is doing for a short period, while a persona is something that runs a little longer. You will see that in a minute. And we record the screen with a frame grabber. We call this machine where we recorded the Rex tracker because we are keeping track of all this video footage. And we also connect to the EOC environment with a component we call Rex Connector, which is responsible for running the sessions for our noisy neighbors. Now we control everything from the Rex tracker and collect both the video data and the telemetry data at the same time. The video data from the endpoint, while the telemetry data from the EUC environment. Like I said, we have those individual workloads. The primary workload, it runs between 45 and 120 seconds. It represents one graphics API. So it can be an OpenGL application. It can be a DirectX application. It can be a video, whatever it is, and we use several applications, for example, for the videos. Now, for our test in this case, we used Media Player, but we could use any other application to do that. And the user interacts with the application, very simple interactions because it's only maybe 45, maybe 60 seconds. At the same time, we are running secondary users. Those are the personas. They run much longer. Typically, we run them between 60 and 90 minutes, and they're there to produce a relatively stable load pattern, so that we can add those personas one after the other and see what happens to the primary user. Now let's have a look at 4 of those personas running. So we have recorded a video. This is something that Chris did. And these are 4 power user personas running side by side, connected from our REX connector. And you see these users are doing stuff. They are interacting with the applications, but it's kind of stable. So the load pattern is always the same. The power user generates a fairly high load, and this is what we wanted because we wanted to make sure that there's something going on in the background. Now, after we have all this data, number one, the MP4s from the screen recordings and the CSV files from the collecting the telemetry data, we feed the videos side by side into a tool we call REX Analyzer. And we also use an overlay view of the telemetry data. You have seen that before. There were several sessions where the REX Analyzer was already used. And if we are feeding the data into REX Analyzer, please bear in mind that the results or the data comes from different sources. Number one, the endpoint, and number two, the session host. So this is the REX Analyzer is the place where this data comes together. And this is why we can play the video side by side. Like on the left side, there is GPU accelerated. On the right side, there is not GPU accelerated. And we color coded like with red and with yellow. And then you see the color coded telemetry data in the lower half of the screen. We call it the quadrant number 5. That's the internal jargon we are using for that. Now, the lab setup is, well, 2 different types of VMs. It's one Azure NV6 VM and an Azure NV16 ASV4. Hey, Chris, where did you build those?
I built them in South Central US because I can get the AMD instances there. And so I tested both in South Central US.
What was the latency from your home environment, your lab environment?
Yeah, so right now it's about 58 millisecond, but I was testing over a weekend, so about 50.
About 50
milliseconds, yeah.
But it's all stable. So what you did is you created the VMs, both types of VMs at the same location. So everything is the same. So there is not some testing where we give one of the VMs an advantage over the other. So everything is fair. And we don't want to compare those head to head. This is what we definitely don't want to do. We want to find out how those individual VMs react under certain circumstances. But you see the differences here because they cannot be compared so easily because one has 6 vCPUs and the other has 16. They have the same amount of RAM, but one has a full GPU and the other only has a half GPU. If you just attended Jit's and Joe's sessions, AMD and NVIDIA, Jit's from NVIDIA and Joe from AMD, they walked us through the different kinds of types of GPUs they have. And so we selected those because their price tag in Azure is pretty similar. One is a little bit more than $1 per hour, and the other is a little bit less than $1 per hour. So we thought this is, well, sort of the best match. Okay, now let's see what we have. So the entire rest of the time of this session is to show you what kind of results we collected. Okay, let's start here with GPU versus no GPU on the NVIDIA side. So let's take a look at those. What does it look like? On the left side, we have the GPU. On the right side, we have the soft GPU or no GPU. And as soon as the graphics kicks in and it starts doing its job, you can see, even on Zoom, you can see that on the left side with the GPU, it's rotating faster. So it's rendering frames in the frame buffer much faster than here on the right side, on the red side. But on the red side, you see that the CPU hits the threshold like 100%. And you also see that the CPU queue length is very high. Well, on the GPU side, you see, well, there is no red GPU because there is no GPU that exists in this VM. It's exactly the same VM, but just disabled the GPU. This is what Chris did. And you see that it's only like 10% of the GPU it's using, but it reduces the CPU load massively. And the RDP output, the frames per second, okay, it's also better if we add a GPU. Okay, that is good. Now let's take a look at the second one if we can confirm this kind of observation. And as we see here, yes, absolutely. So we see a lot more frames rendered per second on the left side with the GPU. We can zoom into this and see it's like a 1,000 frames per second rendered in the frame buffer, while without a GPU, it's 4 or 5. So this is a huge difference. Even though we only have 4 or 5 frames per second, we have 100% CPU load. The GPU on the left side, it's substantial. So we almost use the entire M60 for that. The RDP output is also substantially better if we have a GPU. Wonderful. So we have that on the NVIDIA side. Let's check out what AMD has to say here. Doing exactly the same thing. On the left side, we have the GPU, and on the right side, we have no GPU. Now it's a different workload, and but the thing that we see is fairly identical. You see very high CPU load, even though nothing shows. So the system without the GPU is massively struggling to load the textures into memory and then to run them. So we are here at like 1 frame per second or a frame every 2 seconds, while on the left side with the GPU, everything runs very smoothly. But you see, it comes at a price. And here at the end, you see that we get an error because this is a DirectX application, and well, it runs out of capacity without a GPU, and so we see an error message. This is to be expected without a GPU. This is the typical user experience. Let's do the same thing with another workload. We have still no noisy neighbor running in the background. So again, left side, we have a half MI25 GPU. And also here you see it zooms in and it goes significantly better. It renders 65 frames per second when we zoom in here. While on the other side, it renders like 1 frame per second. The fish are very, very slow. And you see here that the GPU load is not as massive. But one thing that we observe on the AMD side is that the CPU is not producing that much load. That is a very different behavior of the EPYC 2 CPU compared to the Intel CPU. So obviously, if it's not a massively multi-threaded application, it cannot use all the CPU cores as the Intel CPU can. So this is why we have a fairly low CPU load, but a very bad experience if we don't have a GPU. So this is something that we observed here. Now, what we want to do now is we want to have a GPU versus no GPU, but run those 4 noisy neighbors that you have seen previously. Let's start with NVIDIA again, and let's check out the shading first. So it's a DX11 workload, and you have seen that before. And the thing is that now we even get worse performance as we would have expected, because this machine is already under heavy load. We have here a Win 10 multi-user, and now there are 5 users actively working, and we are watching the primary user. While here with a GPU, wow, it still renders like 200 frames per second. And it looks very smooth. And you see the CPU now is also up there at the roof, at the top with the NV6 machine. We see the CPU queue length goes up massively. And this is very interesting to watch, that the performance with the GPU is still very good, even though we added the noisy neighbors to the machine with the GPU, while it's unacceptable on a machine without a GPU. And now we are checking this out if this also happens with the video. And big surprise, at the beginning, the video runs nicely. So you see the CPU is almost at top capacity, but everything seems to be fine. We have a little stuttering at certain places, but this also happens over here with the GPU accelerated. But as soon as the video is turned into full screen, watch it here. You see the artifacts happening here. So suddenly it completely falls apart. This is interesting. So after a while without the GPU, things start going south. This is an interesting observation that we made with the media player. Now let's go to AMD and check out what it looks like when we do the same thing with the AMD machine. GPU on the left side, no GPU on the right side, 4 noisy neighbors running in the background. Now you see, now the CPU is much more loaded because it's different user sessions and multiple applications running side by side. So suddenly we're using the full capacity of the CPU. So without a GPU, we are maxing out the CPU. And we see another thing happening here. We had to introduce that to our latest version of the Rex analyzer, because sometimes the load gets so high that we even cannot collect data anymore. So we are introducing this gap detection. So we're color coding it with this little red transparent line, so that we see that here the machine cannot even collect telemetry data anymore. In the past, we missed that behavior, but now we can see that very nicely. So let's go to the AMD side. Was that correct? Did I miss something, Chris? Now we're doing
the wrong load. Yeah.
Is it? Which one was supposed to?
The second one.
The second one. No. This one shows again on the left side with the GPU. Everything is fine. I missed the NVIDIA one, the second one. Yeah. Okay. So now we're on the AMD side. Again, full blown loaded. We have that again. Okay. It takes forever over here. So it takes almost 30, 45 seconds until we see the first frame here. So without a GPU, the user experience is very, very bad. Look at down here. We are at 45 seconds when we see the first frame. And let's go to the car visualizer workload, again with the 4 noisy neighbors running there. And let's take a look at those. And you will see that the behavior is pretty much the same, because it is very slow here without a GPU. It takes a while until it loads here. Then as soon as it has loaded the textures into the frame buffer, it's very smooth. On the GPU accelerated side, it's very, very slow on the side without the GPU. Okay. Now let's go a little bit forward and see what does it look like if we have 0 versus 4 noisy neighbors. Let's just click here and see the difference.
It's good to say that in this in these runs, both sides have a GPU.
Both sides have a GPU, but now we have 0 noisy neighbor versus 4 noisy neighbors, and you see the frame rate. It's very clear that over here, we get more We get more performance for obvious reasons if we have no noisy neighbors compared to over there. And what we also can see when we do the same thing with the AMD, we're able to have outstanding performance, even though when we add 4 noisy neighbors to the system, it takes forever to load, but as soon as it's up and running, so I do a fast forward here, as soon as it's up and running, it's outstanding. It takes forever until it loads the textures into the frame buffer, but then it works really, really nice. It was the biggest surprise that we have seen. And let me show you the last one. That is the one that Unigine runs again with the 4 noisy neighbors. And this was the biggest surprise for us because you have the, without a noisy neighbor, you see that there's a very smooth performance here on the left side with no noisy neighbor, but you also see a very, very smooth performance on the right side with 4 noisy neighbors running in the background. Okay, we want to create videos pretty similar to the videos that we created for the last test that we did for IGEL. So we have a YouTube video, and you can connect to it using our RDS Gurus website. So you can watch the video. We want to build pretty much the same thing for these things that we observed when doing this absolutely non-commercial tests with AMD and NVIDIA in WVD, so that you're able to compare it yourself. This is what we had for today.
All right. Thanks, Benny.